Such as, with every human activity, the nuclear industry produces waste, which is well regulated and controlled. This kind of waste is radioactive and is called nuclear waste. Since nuclear waste may come from different sources, it must be properly collected. Of course, since it involves radionuclides, some of which decay in very long times, it requires proper management. This is the field of nuclear waste management. Its objectives are to protect humans and the environment from radiation and to avoid imposing burdens on future generations. As the municipal waste is classified on the basis of the material type, so nuclear waste is divided into different categories. On the basis of radioactivity, half-life of the radionuclides it contains and the physical form, or type of emitters, alpha, beta and gamma. Waste classification is important to ensure the safe management of the waste. Since it's clearly not possible to develop a unique classification scheme satisfying the needs of each country, this issue has been addressed at national and international level. As the case of plastic industry that recycle plastic to produce new products, for example Amanda Snickers, nuclear waste also contains a recoverable part. The valuable part of the nuclear waste could be used to produce new fuel and thus new energy. The exploitable part can be separated thanks to reprocessing of spent fuel. These allow for a significant reduction in the waste volume and the time for its monitoring in a repository. Nuclear reprocessing technology was developed to chemically separate and recover fissionable plutonium from spent nuclear fuel. Originally, the plutonium was extracted for producing nuclear weapons, but now it is used to make new fuel along with uranium. And what happens to the remaining waste? Like the black bin goes to the landfill, nuclear waste must be disposed of in special repositories. It is well known that environmental agents like rain could lead to the release of dangerous contaminants from waste in landfill. To protect the surrounding environment, a low permeable barrier is laid down under landfill sites. In the case of nuclear waste, it is even more important to avoid the release of radionuclides in the biosphere. Before storing them in the repositories, they must be immobilized in durable matrices. In general, confinements deals with the prevention and control of release of radioactive material into the environment and also during normal operation or accident. We have seen what happens to the nuclear waste. But what happens to the nuclear facilities? Nuclear facilities require some maintenance to avoid dangers due to aging, as with any other industrial buildings at the end of operation. Conventional plants can be recommissioned, repurposed or demolished, such as the old silk factory in Amandastown. In the case of nuclear power plants, we talk about nuclear decommissioning. The main objectives of decommissioning are to place nuclear facilities that have reached the end of their useful life in such a condition that they pose no unacceptable risk to the public, to workers or to the environment, and to reuse facilities and sites for new purposes. It involves several activities, from the shutdown of the plant and the removal of the nuclear material to the environmental restoration of the site. The whole process is complex and takes a long time, up to 30 years, and it is carried out with the highest safety standards. Radiochemistry is strongly involved in all the activities in the nuclear industry: the nuclear reactor operation, the reprocessing of spent nuclear fuel, the decommissioning of the nuclear facility, the final confinement of nuclear waste, and in general in the nuclear waste management.